Okay, so what we want to start off with today is we want to start off with solving exponential equations. We saw yesterday that we have logs and powers that are those opposites, kind of like multiplying, dividing, add, subtract, powers and roots. Well, logs and exponentials reverse each other. You know, if I have 3 to the power of x equals 81, that is an exponential form. I'll actually move it over there. The log equivalent of that, well, look at this. The exponential part here is this right here. That is the part that is an exponent. And remember, the exponent has two parts. It has the base, which is the number being taken to the power, and it has the power. So the logarithmic equivalent of that, or the log equivalent of that, the base of the log is the same as the base of the exponent. So the base of the exponent is 3. The base of the log is also 3. What changes places are the other two numbers. So log base 3 of 81 is x, is what goes in here. Well, 3 to what power equals 81? The 4th power, right? The problem is your calculator doesn't do log base 3. Your calculator, as we mentioned yesterday, has two buttons. It has a log button, which is implied to be log base 10. And it has an ln button, which is the natural log, or log base e. So we're going to start out with some simple exponentials that have those bases. So let's say I have 10 to the power of x plus 7 equals 138. If I want to solve this for x, now first of all, these are going to come out to be pretty ugly. So what we're going to just establish right now is we're going to round to 4 decimal places. So to solve this, the first thing we have to do, just like in any other equation, is we have to try to isolate the variable. So the first thing we have to get rid of is the 7 here that's added. So we're going to subtract the 7. So we have 10 to the x equals 138 minus 7 is 131. So now we've got that exponential part of this equation by itself, the 10 to the x. To get rid of that, the opposite, as we set up above, is a log. Well, this is 10 is the base of our exponent, so we have to use a log with a base 10, which is just our regular log. So if we do a log to this equation, the log and the 10 cancel out, leaving you just x on this side. Then we have to do the log of 131. So we've got log 131 is 2.1173. Any questions on that? It can get a little bit more complicated. We can have 12 times 10 to the x minus 134 equals 2,863. So again, I have to isolate that exponential part here. What do I have to get rid of first? I have to get rid of subtraction. How am I going to get rid of it? Add 134. So what's left over here is 10 or 12 times 10 to the x. Over here we have 2,997. What's that? What's that? There you go. Divide by 12. Perfect. Divide by 12. So now we're going to end up probably with some decimals. 2997 divided by 12 is 249.75. Now that one wasn't too ugly, but it could be ugly. It could be that repeating decimal or non-terminating decimal that goes on forever. So what I'm going to show you here in the next step of the calculation is how to keep that in the calculator. Notice that's on my calculator screen. I'm not going to hit clear. Yep, we're going to use the second answer key. So now I have to log this to get rid of the 10. So the log and the 10 cancel out. To do the log, of course, base 10 of 249.75, I am going to hit log. And yes, I'm going to hit second answer to tell the calculator to use that previous answer. And I get 2.3975. Does that make sense? So what if there are different bases here? What if we have 7e to the x or e to the t, whatever you want to use, plus 6 equals 38. So I'm going to start out by subtracting 6. Good. Yep, so 7e to the x equals 32. And you are correct. We'll divide by 7. So e to the x equals 4.57142857,143 approximately. We'll put it in the calculator, 32 divided by 7. So we have that in the calculator. Now what do we have to do? Well, it's not 10 to the power anymore. It's e. So it's ln. You got it. ln stands for the log base natural. E is the natural constant, so ln is natural log. So the ln and the e cancel out. X equals, we have to do ln of that. So I'm going to do ln, and again, second answer to tell the calculator to use that previous answer. It equals, I get 1.5198. So x is 1.5198. So we can make it a little more complicated for ourselves. We can run into something like this. This is actually basically like solving two equations. The first thing we have to do is we have to isolate that exponential. Of course, that's this piece here. What are we going to do to isolate it? We'll subtract the 17. So we have 3. Hold on just a second for it. So 3 times 10 to the power of 5x minus 2. And this is 360 over here. So you're right. Then we have to divide by the 3. So 10 to the 5x minus 2 equals 120. And then, well, now we've isolated that exponential, right? It's just 10 to the power of stuff there. Doesn't matter if there's a bunch of crap in the power. It's just 10 to that power. So this is a log base 10, which is just a log. So here the log and the 10 to the power of cancel out. So all I'm left with is my exponent. 5x minus 2. I have to do the log of 120. Careful. Should be 2 point something. 2.0792. Now what do I have to do? Now I just have a simple linear equation. I got to solve it for x. So I'm going to add 2. So 5x equals 4.0792. Now I'm going to do this in the calculator so that I keep this running total in my calculator because I'm going to need that. So I add the 2 to get 4.079. And then yes, my last step will be divide by 5. So I'm going to divide by the 5 here, which is going to give me 0.8158. Make sense? I want you guys to try one in your notes here quick. So 5 times e to the power of 3t plus 7 minus 9 equals 1,827. The t is going to behave just like x. So what's the first thing we're going to have to do here? Hey, come on in. No, they're just working. So what's our first step here? Adding 9. So 5 times e to the 3t plus 7 equals 1,836. And then divide by 5. So e to the 3t plus 7 equals 367.2. Is that right? Yeah. Then what? Now, yep, we isolated the exponential, so it is ln. So that cancels out. We've got 3t plus 7. ln of 367.2. 5.9059. Then what? We will subtract 7. So 3t equals negative 1.0941. I'll put it in my calculator here quick just so I have the running total here. And yes, then we're going to divide by 3. So t equals negative 0.3647. So now that only works so far if we have a log base 10 or an exponential base 10, so we can use a log base 10. Or an exponential base e, so we can use that natural log, or log base e. What if we have a log with a different base? Hit Google. Well, there is a change of base formula. If I have a to the power of b, well, let's do it this way. If I want to do a log base a of b, where a is something other than 10 or e, I can find that by doing the log base 10 of b divided by the log base 10 of a. For example, let's do the log base 2 of 8. I know the answer of that has to be 3, because remember, what the log is asking me is 2 to what power equals 8? 2 to the third power equals 8. So I know that answer has to be 3. Does that make sense? Yeah, that base to what power equals that number. So let's try this. Let's try log of 8 divided by log of 2. So log of 8 divided by log of, oops, I gotta put my parentheses in. Log of 8 divided by log of 2. And it does give us 3. So it works out. In fact, we could use either log or we could use ln. If I use ln of 8 divided by ln of 2, it'll still give us 3. So either one of them works. So we can change the base by using that formula. So if I happen to run across an equation like 2 to the x plus 5 equals 70, I can solve this. First of all, I have to isolate the exponential part, the 2 to the x. So I'm going to subtract 5. So 2 to the x equals 65. Now to solve this, though, now it's 2 to the power of, I have to do a log base what? The base of my exponent is 2, so I have to have a log base 2. So this here is log base 2. Now on the left side, it really doesn't matter. There's nothing to calculate. The log base 2 and the 2 is the base of the exponent cancel each other out, leaving me with just that power, which is x. Over here, I actually have to calculate the log base 2 of 65. And on the calculator, that's just going to be log base 10 of 65 divided by the log base 10 of 2. So log of 65 divided by log of 2. 6.0224. Any questions? So I can get really carried away if I want to. Two times 5 to the power of 2x minus 3 minus 11 equals 132. Well, talk me through this. I have to isolate my exponential, which is this first, right? So first step is add the 11. So I'm left with 2 times 5 to the 2x minus 3 equals 143. Then what? Divide by 2. So 5 to the power of 2x minus 3 equals 71.5. Not divide by 5. It's 5 to the power of. So that the 5 is the base of an exponent. So to get rid of the base of an exponent, we use a log. That's a base 5 exponent, so it's got to be a log base 5. So over here, we're going to use a log base 5. So the log base 5 and the base 5 on the exponent cancel out. That gives me 2x minus 3. Here we have to do log base 5 of the 71.5. How do we do that in the calculator? A log of 71.5 over log of 5. So log 71.5, close my parentheses, divided by log of 5, 2.6529. I'll wait till you get your picture there. So now we've got rid of the exponential, so we can solve this linear equation for x. So all we have to do is add the 3. 2x is 5.6529 and divide by 2. X equals 2.82645. Okay, that's enough for today. Your time is up anyway. So out of that packet, on page 481, I want you guys to try to do 1 through... Let's do 1 through 27, the odd. That's just on solving these exponential equations by using logarithms.